everyone. From this lecture, I am going to start about circular dichroism spectroscopy, which is important to find the stereochemistry of organic molecules. So first we will see what is electromagnetic wave. So transmission of energy through a vacuum or using no medium is accomplished by electromagnetic waves, and which is caused by the oscillation of electric and magnetic field. And these electromagnetic waves are also known as electromagnetic radiation or electromagnetic light. So this is electromagnetic spectrum which has different radiation at different energy levels. Now, what is plane polarized light? As you know that if the vector of the electric field oscillates along a straight line, then the waves, because here this is in all direction, but after passing through a polarized axis, it just having in one direction, because the vertical vibration got partially absorbed by this part, and the linearly polarized light only transmitted. So that has oscillation only in along the straight line, and this light is called plane polarized light or plane polarized or linearly polarized wave. Now, these two following animation showing a wave that is plane polarized in a vertical plane and in a horizontal plane. So this is right. Now, when two electromagnetic waves polarized in two perpendicular planes are present simultaneously, then the electric field are added according to the rules of vector addition. So now the properties of the resulting electromagnetic radiation depends on the intensity and phase difference of the component waves. So based on that, we will see here. So the following animation present the superposition of the two waves that have the same amplitude and wavelength are polarized in two perpendicular planes. One is vertical and another, as you can see, this is green one is vertical and the red one is horizontal. Now they can superimpose in the same phase or on the different phase. So if oscillating in the same phase means that the two waves reach their peaks and cross the zero line in the same moment, and the superposition of the two waves that have the same amplitude and wavelength are polarized in two perpendicular planes and oscillate in the same phase. But when two waves plane polarized in two perpendicular planes meet out of phase, then the wave resulting from the superposition of two waves will no longer be plane polarized. They are circular polarized light. So the superposition of two waves that have the same amplitude and wavelength are polarized in two perpendicular planes, but there is a phase difference of 90 degrees. As in the case of this green and red waves, they have difference of 90 degrees between them. And in this case, they have difference of minus 19 degrees between them. So this is right circularly polarized light, this is left circularly polarized light. Means if there is a difference of 19 degree or minus 19 degree, they will give opposite circularity lights, which is known as circularly polarized light. So circularly polarized waves, these are the example or animation for circularly polarized light. So superposition of circularly polarized waves looks like if you mix the right-handed and left-handed circularly polarized light, they gives the plane polarized light. So it shows that plane polarized light is a mixture of right circularly polarized light and left-handed circularly polarized light. So this is any linearly polarized light waves can be obtained as a superposition of a left circularly polarized and a right circularly polarized light wave whose amplitude is identical. Now, circular dichroism spectroscopy. So circular dichroism is the difference in the absorption of left-handed circularly polarized light and right-handed circularly polarized light. Means difference between LCPL and RCPL, and occurs when a molecules contain one or more chiral chromophores. So circular dichroism is the difference of RCPL and LCPL, where lambda is the wavelength. And the circular dichroism spectroscopy is a spectroscopic techniques where the CD of molecule is measured over a range of wavelength. So CD spectroscopy is used extensively to study chiral molecules of all types, because the circular dichroism will observe only when molecule will have chiral chromophore. but in the study of large biological molecules where it finds its most important application. A primary use is in analyzing the secondary structure or conformation of macromolecules, particularly proteins. As secondary structure is sensitive to its environment, temperature, or pH. And the circular dichroism can be used to observe how secondary structure change with environmental condition or an interaction with other molecules. Now, measurement carried out in the visible and UV region of the electromagnetic spectrum and monitor electronic transition. And if the molecule under study contains chiral chromophore, then one CPL state will be absorbed to a greater extent than the other CPL state, and the CD signal over the corresponding wavelength will be non-zero, means it will have the positive and negative, or maxima and minima. So a circular dichroism signal can be positive or negative depending on whether CPL is absorbed to greater extent than RCPL or to a lesser extent. So if LCPL is absorbed to a greater extent than RCPL, then CD signal will be positive. If LCPL means left-handed circularly polarized light absorb to a lesser extent than right-handed circularly polarized, then CD signal will be negative. So this is positive, this is negative. Now, application of circular dichroism. So circular dichroism is a consequence of the interaction of polarized light with the chiral molecule, and the vast majority of biological molecules are chiral. And for instance, 19 of the 20 amino acids that form proteins are themselves chiral, as are a host of other biologically important molecules, together with the high structure of proteins, DNA and RNA. And the highly chiral chemistry of biological molecules lends itself well at analysis by circular dichroism. And the study of biological molecules is the main application of this technique. And a powerful application of circular dichroism is to compare two macromolecules or the same molecule under different conditions and determine if they have a similar structure. And this can be used simply to ascertain if a new purified protein is correctly folded, and determine if a mutant protein has folded correctly in comparison to the wild type, or for the analysis of biopharmaceutical products to confirm that they are still in a correctly folded active conformation. So overall, this technique has an application in biomolecular chemistry. And this is the CD spectra of 1 millimole solution of L-tryptophan, which is in red, and D-tryptophan, which is in blue. So this shows that two different isomers of tryptophan showing different type of CD spectra. Now, optical activity. The compound which are having the ability to rotate the plane of polarized light are called optically active compound, and this property of compound is called optical activity, and it is measured by polarimeter. And compound which rotates plane of polarized light to right, that is clockwise, is called dextrorotatory and is denoted by plus sign. If the compound rotates polarized light towards left side, means anti-clockwise, is called levorotatory and is denoted by minus sign. So what is specific rotation? It is defined as a rotation produced by a solution of length 10 centimeter and unit concentration 1 gram per ml for given wavelength of a light at the given temperature, and it is denoted by alpha. And it depends on various factors like nature of substance, length of the column, concentration of the solution, temperature of the solution, nature of the solvent, and wavelength of the light used. Now next term we use circular birefringence. So they are materials having another special property. Their refraction index is different for the left and right circularly polarized light, and this phenomena is called circular birefringence. So as discussed earlier, linearly polarized light can be obtained as the superposition of left circularly polarized and right circularly polarized light wave. Therefore, if linearly polarized light traverses a medium that shows circular birefringence, its properties will change because the two circular polarized components slow down in the medium to a different extent. And circular birefringence rotates the plane of plane polarized light. Now, optical rotatory dispersion, that's ORD. So ORD refers to the change in optical rotation with the change in wavelength of light source that is applied only in optically active compounds. So ORD curves in recent years are made using structural determination by comparing the curve obtained from compound believed to have related structure, particularly applied to carbonyl compounds. An optically inactive substance will retard the speeds of two circularly polarized components to the same extent with no net rotation. However, the speed of the circularly polarized components are retarded by an optically active substance to different extent, resulting in the rotation of plane of polarization light. So this is the ORD curve, and A represent the plane positive ORD curve. The specific rotation increases with the decreasing the wavelength. As wavelength is decreasing, the rotation is increasing. B represent the negative ORD curve, and plane implies that there is no maxima or minima in curve exists. And thank you very much.